Hello everyone, this is my first recording. I'm trying to decide if I like to do this or not, so we'll see how this one goes. Today I'm going to analyze and look at the performance of Oracle 12c's new identity columns. As many of you know, Oracle 12c came out a while ago. People are trying to roll it into production. One of the new features is a identity column very similar to SQL Server and other database engines. So I thought that I'd look at the performance of that, especially as it relates to Oracle RAC implementations. I wrote the book Oracle RAC Performance Tuning, and in Chapter 3 I discuss at length a number of issues related to sequences in Oracle RAC. And sequences can sometimes be a performance bottleneck if not handled properly. As you are well aware, a lot of times sequences are simply used to populate synthetic keys in a database table. So I thought I'd take a look today and see if I use Oracle 12c's new identity columns, am I going to have similar performance, better or worse? How's it going to behave? So with that in mind, I think we just need to get started here. Okay, so here I just have two tabs in my terminal shell. Signed on to two different hosts in my Oracle RAC cluster. These are, as you can see, Oracle 12.102. This was an empty database created as 11.204, and it was subsequently upgraded to 12.102 in preparation for a larger project. But the database is essentially empty, so there's really not much in it. So the first thing I'm going to do is just create a test user to use for this. And it might help if I sign on first. And I'm just going to take the easy way out and just grant DBA to my user. Obviously we wouldn't do this for real, but we're just playing around, right? Okay, so I have a script which is going to create a table, create a sequence, and create a trigger. And we'll see this as it runs. So the first thing it does is it just creates a simple table. The table has two columns, ID and the current time. And then I create a sequence. Because this is Oracle RAC, I set a high cache value to help with performance, global cache transfer information across the private network. That's pretty standard on what I typically do for Oracle RAC. Start at least 1,000, sometimes it's more than that for the cache value. Definitely I stay away from no cache, and I stay away from the order parameter or directive on a create sequence. And then you can see that I just created a simple trigger, and all it does is it's just going to populate the ID column with the sequence's next value. Over on the other host, my database name is RESP, and that is simply just research. This is my research test bed, and P for primary because it also does have a 2-node rack standby, and this is the second instance there. So now that I have my environment set, I can connect. Okay. So the next thing I have is I have a simple script which I will show you. What all it's going to do is insert 1,000,000 values into this table that we just created. Now normally we would not see in a production environment a loop such as this where all you do is you import or insert 1,000,000 rows in rapid fashion. So this isn't exactly indicative of a real-world test. But in Oracle RAC with multiple concurrent users, you may see a very high rate of insert concurrency on these sequences and on this table. And that's what we're trying to simulate here with just a simple test. So please don't take me to task that, well, this is not something you would really see in production. No, it's not. And we're just playing around today. We're not trying to say this is exactly a production environment. If this were a production environment I were trying to simulate, I would be using production code. But I'm just trying to take a look at the Oracle 12c identity feature and see how it behaves. So we're going to run this, and we're going to run it in parallel on both nodes. So here I'm going to start this on one instance and start it on the other. It's running in both. As you can see, I had echo on and host will 1. And I'll come back when this is done. Stay tuned. Okay, you can see that the loop is done running. It's done running in both. In host 02, it was about 3 minutes and 13 seconds. And host 01 was very similar, 3 minutes and 18 seconds. For me, it was about 3 to 5 minutes as I sat here and got something to drink. For you, it was probably just mere seconds. The magic of editing. So the total, before I go too much farther here, one thing I want to do is I have a script which just shows me my top 5 wait events for my current session. So, and you can see the contents of the script there. It's pretty similar, pretty basic. This script is actually part of the code library for my Oracle RAC performance tuning book. If you have the copy of the book, you can see in the front where to go download this script. But you can see the contents there too. It's no big secret what this script does. But it's interesting to look at what the top 5 wait events are, and we typically see in Oracle RAC environments a lot of global cache transfers when we have sequence contention and this row cache lock. So those are pretty standard to see. If we go over to host 02, it's very similar. It's not exactly 100%, even though they were both doing the same work. But it's very similar, and we're looking at very similar numbers here, so that's not to be unexpected. So now I kind of have a baseline here established with something that I've been doing since my first days of Oracle. Create a sequence to populate an ID column, create a trigger, and have the trigger populate that back and forth. So this will be the baseline we use. We now know we're looking at about 3 minutes and 15 seconds of runtime for each of the 2 scripts. And we now know what our wait events look like as well. So next, what we'll do is we will create a Oracle 12c table that has an identity column. And then we'll use a similar insert script in a loop just to stuff a million values from 2 different sessions on 2 different nodes. So let's see how that goes. Okay, so I just cleared my screen because we're going to start here with the identity columns for the Oracle 12c database. I wanted to keep this test to be as similar to the other baseline test as possible. I think that's always an admirable goal. So in that end, I'm just going to stop the database. This database had come up on, from fresh when we started with the test, so I should probably have this database come up fresh again to start the new test and compare to the baseline. So it's probably going to take just a minute or 2 for this database to come down, and then I'll start it back up, and then at that point then we can resume the test. Okay, the database is down, so now we'll start it. all instances will come up. And there we are. Okay, so I'm connecting as my test user. I will make a note that your compatible parameter must be set to 12 in order to use this new feature. That should be pretty obvious. And I'm set at 12.10, so I should be good. We'll set echo back on, and then you could see my script to create my test table. Again, it's still got the same columns. The ID column as a number data type, and the cur time column as a date data type. But I have specified in here generated always as identity, so that way I can always have that identity column populated for me. And I have a similar script. We'll take a look at that. It helps if I spell it right. Okay, and again, this is just doing the same loop. The only difference is instead of having a trigger populate the ID column, Oracle 12c's identity feature is going to take care of that for me. I could have probably done something fancy like said insert sysdate, but I wanted to keep this exactly the same as it was before. Let's just make it as identical as possible here. So we'll sign on my other host here. And I will get ready to run this. We'll copy and paste that over to the other window, and we will give them a go. So here we're just going to run the scripts, and they're running, and we will just see how long they run. We'll check back in just a little bit and look at the results again. Okay, and it finally finished. I had to pause the recording because it was taking a while. But as we can see on this first instance, the runtime was almost twice as much. If you remember, the other ones were 3 minutes and 18 seconds and 3 minutes and 13 seconds. And here on this one, we're up to 6 minutes and 20 seconds. And on host 02, 627. We can look at the top 5 wait events for each session. And we still see the same dominant wait events here at play. But what's more interesting is the total waits. Those went up significantly, and since the total number of waits for each of those 3 events went up, then the total time waited went up as well. Let's look back in the first session as well. And again, very similar, over 40,000 waits for each of those 3 wait events. So this is quite the killer. So out of the box, doesn't seem to be a great thing to do if you want to use Oracle RAC and the new Oracle 12c identity columns. So now the big question is why? Why does the Oracle 12c identity column perform so much worse? And it shouldn't be a surprise that what Oracle 12c does under the covers behind the scenes is that it uses a sequence of its own. And we can see that. I have a another script here. Which just looks at the user sequences table. Remember, we created this user at the start of this test. So it was an empty schema at the start, and we explicitly created the sequence for our baseline test, and that's here, this test sequence. And we could see its cache size of 1,000. To implement the identity column, we can see here that Oracle has created a sequence for us. And notice its cache size is only 20, and that's way too small for Oracle RAC implementations for sequences that have a high degree of contention, which is what we basically did here. Again, I talk about this at length in Chapter 3 of Oracle RAC Performance Tuning, and show a number of cases where the cache size needs to be increased. It's nice to see that we don't have the order flag. That's the third column, so none of these have the order flag, but this cache size is too low. So it would be nice to actually increment that if this is Oracle RAC. Unfortunately, we can't. When I try to, I get tossed or a 32793 error, cannot alter a system generated sequence. So Oracle's explicitly stopping me from doing that. So thankfully for us, all is not lost here. We just can't modify the sequence directly, but we can use the alter table command to modify its behavior for us. So the way we would do that is just quite simply alter table and give it the table name. We're going to modify the ID column, and we still want this to be generated always identity. But now we're going to say what the increment can be on this identity sequence. We're going to still increment by 1, but it's nice to know you could change that to 10 or 20 or 30 or whatever you want. And we're also going to specify a cache size. And of course, as the way things will go, I missed one simple little keyword in here. So the table's been modified here. And now, if we go to our user sequences script, we can now see that the cache size is 1,000. So that's much better. So what I'm going to do next is I'm going to rerun my test, and with the new cache value, I'm going to bounce the instances, bring them back up, and then I'm going to run the test again, and then I'm going to report back the results. So we'll just fast forward to time here. Okay, and I'm back. One thing I did want to note is before I brought the instances down, I did truncate the table so that it's empty and we're starting from the same place we were before in the previous test. And then you can see that I just simply bounced the instances, signed on, and I am running the same script in both nodes at the same time. When it ran, notice the elapsed time in this instance was 1 minute and 44 seconds. And in this instance was about the same, 1 minute and 44. So if you remember, our baseline was about 3 minutes and 15 seconds. Our initial implementation of the identity column was over 6 minutes, but by adjusting the cache value on that sequence that Oracle creates for us, we were able to get the runtime down to half of what the baseline was. And this is great news. So it behooves us to go back and look at the top 5 weights. And they're still pretty much the same weight events here. And in the other session, mostly largely the same. Overall, I think that this shows us that an Oracle RAC, that one can certainly use the Oracle 12c identity column to great success. I think this is a great way to go going forward. But I think this test also showed us that we shouldn't just implement things on blind faith out of the box, because by doing so, we could have actually had worse performance. But by simple testing, we were able to come up with a way to not only implement this, but implement this and get better performance for our applications. At this point, I think this concludes my little demonstration. I hope you enjoyed it. I will put up a slide showing some contact information. I plan on doing a few more of these in the future, so look out for them. And thank you for attending.